Okay. Let's see. The audio seems fine. Mhm. So we have the Lemon bootloader configured, and um, right now all our kernel does is just when it boots up, it just hangs, right? And the first step would be writing something, list, writing text to the screen, and if we were on VGA mode, which is, I think, limited to, yeah. So if we were in protected mode, we'd be able to use VGA. And I think we can still use it, but we'll have to like jump back to legacy mode or something like that. And so anyway, if we were on VGA mode, then um, we could just do something like so we have the let's see let's say right, and we have let's assume we have the frame buffer, right, and it's usually located at something like this at this address, and with VGA we could just do something like and this would work like we would see A being printed to the screen. um, However, since we're using the Lemony bootloader, which configures UEFI and all of these protocols, uh, such as VB, or it's for VIOS and GOP. What is even GOP? I don't even know the full form. Yeah, it is a new standard for UEFI that superseded VESA BIOS and UGA. Okay, more. Yeah, since our bootloader configures these things, um, we have like access to the entire monitor. And but the difficult thing is that we cannot just write ASCII text into this buffer and expect things to just work as expected. So as always, we're going to use OSDave as our like main resource, and let's look at what it says regarding regarding how to like actually write text when we have a like modern version of a frame buffer, right? Mm, 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 mm. So yeah, um, in order to actually write text, we'll need a font. So it basically lists out the pixels that we need to map for like each glyph character. So even ASCII is a glyph uh, for the font, right? And let's see. So we'll have to load that font data into an array, and then we'll basically yeah map like we'll basically color pixels based on if the bits are set in the font data, right? Mm, so regarding font, the format that uh, like format that at least like Linux uses is called PSF, PC Screen Font. So this is what you will see. So this is the font that we will see when we get to the console, at least on Linux. And the like OSDev article suggests we use this command to find our console fonts, but that's not going to because I'm a like NixOS user. I'm gonna have to follow the Next.js wiki. And uh, for me, the PSF font files are located. Let me go back to this. Username, and yep. So for me, the fonts, I cannot type this. For me, the fonts are going to be at this directory, and the default font, I think it's called Terminus or something. Yeah, it's this font. So this is the font that we're going to use for our kernel, and let me copy that over to our kernel. Yeah, seems like I've already copied it. Oh, yeah, it's gzip, so I need to dash d. Yep, and now we have the actual font file, right? Which is of course in the PSF version 2 format, which has I guess 256 characters, and I suppose this is the width and height of each glyph. So I'm not sure what 8 means. Is that bytes or bits? Let me look. Yeah. Bitmap font currently deployed by Linux kernel for console fonts. Found with the source code of blah blah blah. Header, two types of header. So for us, it's going to be PSF2. All multiplied integers are in least significant order. Little Indian. We won't have to worry about Indianness since x8664 is Little Indian, and apparently this is also Little Indian. So we can just directly read stuff. It's going to have okay the height and width. Height of each glyph, width of each glyph. Oh, okay. So it's 8 pixels, and we don't know like how many pixels each glyph is, but we know that it's 8 pixels wide and 16 pixels high, I guess, of height. Yeah. Um, let's see, PSF2. So these are supposedly the uh, header fields, and after this final field will uh, I suppose we'll have the actual font data, right? Mm, yeah, the actual glyph immediately follows the header. Each bit in each glyph represents one pixel in the font. Bit, yeah, okay. 0 for one drum, 1 for drum. Okay, so if we are looking at A in the uh, 12 by 12 mm, PSF font, let's see. So it's 12 by 12. So 12 rows and 12 columns, right? And okay, so this makes sense. I mean, if you just look at the A, then it kind of looks like. So we have this. How do I? It's not even. Not sure if you can see it, but if you just look at the one, then it kind of traces like an A, right? So what we need to do is like wherever there is one, we basically uh, fill that corresponding pixel in our frame buffer with some color, right? Let's say white. So and if we fill like each pixel accordingly, then we'll see the actual glyph in our console, right? Mm, so since we don't have a file system yet, we're probably going to have to load the font file. in our kernel itself. And there, I think there are two ways of doing this. Let's see, I looked over, like I glanced over this article a while back, and yeah, so this is the header for no, where is PSF2? I guess this is PSF2. Hmm, seems like it, but so there are two ways of doing this. Either we load the PSF font itself and then read stuff um, using the header, or we do. I think it was somewhere. Oh, maybe it's inside this article. Mm. No, not this one. I guess I forgot which article it really was. Let's see. I mean, I know it's one of these, but oh no, this one. GOP running more. Hmm, I think it's. Nope, nope. Okay, let's see. Printing the screen. Well, I cannot find it, but as far as I remember, so one way would be to read the like directly embed the PSF file itself, and another way would be to load uh, to like convert this font file into an ELF file using object copy. Yeah, so I've done this before, and um, this will this will convert um our font into like uh, an ELF binary, and the linker I suppose will handle like where the actual binary needs to be uh, put. But in our case, I think I'm just going to use the PSF font itself. So let me look over. Yeah. So let me place this somewhere. I don't need the font button. Let me uh, take this inside kernels. So yeah. Okay. So load the font data using embed file. Let's name it. And then we need to define the header, which is yeah, this one. Let me just copy it and I'll translate it into Zig. Start U32. Uh, uh, um. Oh, I I forgot the syntax. No, how do I? get this to work. Let me just uh, so like first I need to do this on header, right? ES header this struct is all of these are U32, right? U32 um, damn it, U32 U32. You know what? I'm just going to write myself magic version size flags uh, god damn it 32 32 flags numglyph okay, there we go. So we have the PSF, let's call it 2 magic. We have the header PSF, let's call it 2. I think I can do. Is there a way to do like that so that the ordering doesn't get messed up? Master, I think I'm using, yeah. Before I try the pact, pact struct. Okay. Unlike normal pacts, are like guaranteed in your layout. Okay. So I just do pact. Yeah. So now we need to um parse this header. So in K-min, let's do const going to str is going to be a header and then on data. We need to cast this as yeah. So if we read, mm, I kind of want to test if I'm doing things right, but since we don't even have like uh, any way to like print stuff, I think what I'm going to do is let me use the limit sig. No, not this one. Yeah, it's gonna take. I can need. Come on. come on, revoke. Okay. After no, source name. Yeah, I'm just going to copy this stuff and copy this stuff and call it uh, test no draw stuff. Yeah, and copy it over here. So if we call this function, then it's basically going to um, draw like horizontal line, diagonal. What I'm trying to do is like we're going to test, and if the test succeeds, we're going to call this function, and if it doesn't, then I'll see nothing. Right? Sgr dot magic. Yeah. Let's see if it is equals to ESF. Yeah. If this, then draw. Rest of. Yeah. Let's not call it pub right now. I don't. It's pub. Yeah. So if I do what increases pointer alignment, this I need to do line cast. Okay, so we are able to read the font header, right? So you know what? Let's just uh, make this into a function so that I'm going to put it here. Get self. Let's say it's going to be some natural PSF2 header. And let me copy this. Return. Get PSF2 header. And this will work, right? Oh, I could probably just do test. Oh no, I cannot do it right now. So I cannot just do test, right? Because we have probably don't have a lot of things set up. So this is fine. And let's say is PSF2 it returns a bool. Return. So I can just do if means PSF2 then draw stuff. It should work as before, right? Yeah. And if our header was like slightly off, let's go to 3, right? And this should not work. Yeah, nothing works. Okay, so let's see. Apparently have a viewer. Wow. Um, okay. Let's continue. I have this like terrible cough that just does not seem to go away. Uh, where was I? Oh, so we have a way to read the header, right? Now, what we need to do is let's see. Let me, okay. Uh, yeah, drawing text. To draw a character, I'll need to. So I suppose this is the height. So we're iterating over the height. In this example, uh, for 8 by 16 font, this glyph is 16 bytes long, and every byte encodes exactly one row of the glyph. So 8 bits. Oh no, every oh, so this is one row. This is another row. Um, yeah. So this is where I was like not sure why I couldn't find this earlier, but um, this is like where this is how we can like convert that PSF font into a ELF file and then load it directly into our kernel image. So what they are doing is, I guess, uh, I don't need, I probably not won't need to deal with this. Displaying a character. Yeah, put char. How many bytes encode one row? One row. Okay. Font width. What is PSF font? It's this one. So it's this header. We're basically reading the header, right? And we're skipping the header, I suppose. Oh no, glyph. How many glyphs there are? How many bytes per glyph? Okay, let's see. You know what? Let's try to function that. So right now, what I want to do is um, so I kind of just want the font data itself, um, so that I can like directly do something like so. If I have font data, then if I like give the ASCII value of A, then I think it will give me uh, the glyph for the corresponding um, ASCII character. I think let's double check that. No, font data input. Okay, well, let's just try it out. Um, data size and okay, let's do font start. Um, should have a header size value, right? Okay, so if I do something like font dot, let me do get basic to header and skip for the header size. Not font data. Let's say font data. No, mm, let's call it um no uh, raw raw font data. So this one can be font data. Okay, let's cast that as a pointer to like u8 2 bytes. Constant pointer to bytes. Okay. Now, how do I get a glyph? If I do font data and then so there's like a code point for A, right? Um, ASCII value in 32. Let's call it use size, right? Um, can I do Linkcast? Or do I even need to do this? Probably not. Oh, let's just say yeah, 6.5. So we start from the 6.5, right? And since each glyph is going to like consume some number of bytes, there must be a bytes per glyph. Yeah, so each glyph will consume some number of bytes I need to get. So like each glyph isn't going to be just a single byte. It's actually going to be an array of 16, I think, and each uh, element in that array is basically going to be the single row. Where was that diagram? Yeah. So if I access like uh, A, then I'm going to like need to uh, take this much uh, um, this many elements, and then each element in that array is going to be this particular row, and if there is like a one in that particular byte, then I plot the pixel for the uh, corresponding position in our frame buffer, right? Uh, so let's do, so since I'm going to need to return an array, let's say glyph uh, yph to phone data. We start from the active value, and then we get like ASCII value plus sorry, ASCII value uh, mm, mm, what no no like its value is going to be header plus I mean header dot bytes per glyph, right? Okay, let me rewrite this as glyph offset, and the starting offset is going to be this thing, right? And so we start with this offset, then we go until when we get this many bytes, uh, bytes per glyph. Yeah, and this is going to be our glyph for, in this case, A, right? And how do we plot that? Well, we must have our frame buffer, right? Let me just get this real quick. Yeah, I have the frame buffer. We don't iterate up to 100, we iterate up to bytes per glyph height. So in our case, I think the height is just going to be 16. Let me just start a quick test name. No return. If error that height equals 16, then draw stuff. So replace game in with test name. Yeah, return what? Mhm. Yeah, awesome. So, so it's definitely not 32, right? I know that. And we see nothing, right? And width should be 8 because I like we are using 8 by 16 terminal font. Mm. Yeah, midterm width should be 8. Yep, yep, awesome. Let me go back to Keymain, but we don't want to assume like it's 16. So let's just loop over. I want to call this height so row, and then we loop over the row. No, the width code, or let's call it. Yeah, let's just call it bit. Oh, I mean call. Just I need to do this real quick. Okay, sorry about that. I needed to take a piss, basically. So how do I get uh so like right now what we have is we're like seeing this value, right? So if I do get no, so I have the glyph, right? Glyph, and if I access the row, then um, I should get uh, this value, right? Hmm, kind of stuck. God damn it. Okay. So I was looking for no, not this one. Yeah, I was looking for this code. Yeah. So if the particular row is has what is this doing? Oh, okay, so we're accessing that uh, a particular bit, right? And how do I get the bit? So we'll need to start with whether select. We need to start. No, let's see. Mm-mm. One, let's and shift it over to the right by what if I do this? No, damn it. I'm just going to do with the 0 and then set it right there. This should uh, give the bit mask for a particular bit, right? Mm, yeah. So this is our mask, right? And so if I get the row and then add it with the mask, if this is a 1, then we just plot the pixel, right? And how do I get the pixel? What? Oh, I'll need to like have an x and y values as well. Okay, see. And make x, x, y 0, and x var, this size, and I need y. Let's do x and y, this size is 0. So we're starting with 0, 0. How do I get to x comma y? So how do I get to x comma y? The frame buffer has pitch, which is I think how many bytes? Let me check that as well. Too close already, man. Frame buffer. Mhm. Is there no description for pitch? Let me check. Yeah. Video mode. Yeah. Well, this has no info as well. But as far as I remember, I think it's how many bytes in each row, or I think how many pixels in each row, and um, let's see. No. So to get to the get to a particular row, um, which I need to like multiply y with the pitch. Yes, so this is getting me to a particular row, right? And to get to a column, I think I can just do x plus, right? This should give me the pixel offset. Yeah. This is, yeah. Do this and so the pixel offset is going to be the y position plus our um, row that we are on for the glyph, and then as for x, this column. Yeah. Then we just map. We just write a white color to that particular pixel offset. Okay, let's see. What's the reason? Cost. Okay, since I'm not ready. Yeah, so I don't need like X and Y right now. Let's just do row and column. Mhm. Let's open the code. Idle time. Mhm. Let's do return. Oh, not where. Oh, can I not do that then? Okay. I'm gonna to play with the type system, iterative type system right now. So what if I do echo data header size? Hmm. So that worked. Can I do this? Nope. Well, let me just give like let me just make ChatGPT to do it. Okay, start a new window. Yeah. So I have, but it's not letting me. But ChatGPT. Try first. Come on, come on. I didn't. I'll do it in this window. Okay, empty chat. I have this all. Okay, you know what? I'm just going to stop the stream for now and like figure this out. Okay, apparently it was like as simple as doing this. So I hit specify the type in the very beginning, and I just like to do this. And our font data will be a slice, right? Mm, Okay, let's do micron. Ah, I need to fix this. So as with maybe how do I do this? Have you three found your size? Oh, okay. So this should be U3 and what? This needs to be U8. So what? Okay. Oh my god, this is painful. Ah, okay, it worked finally, but our kernel reset has is resetting. Right. Yeah. Let's see. I kind of want to clean this up a bit first. How can I do that? So to get the glyph data, I think I can just do yeah, fn get glyph, right? And we're going to get like take the character, which is going to be lit, and we're going to return a const lit, which is the glyph, right? So I need a header, the font data. Character. So there's going to be a num glyph, and it our character should not exceed exceed that value, but since we're using U8 anyway, uh, it will not exceed a U32, right? Okay, glyph. So just return that. So let's just put the font data as the input itself. Font data. And then I can move over up and still need this. I still need the header anyway. Oh, come on. What am I doing? I need the I need these two things, right? Hmm. But I won't need the font data here. So we have the header, we have the font data, we have the ASCII value. Let's get the click and get this and give it the font data, and then as for the ASCII value, let's just do a. Okay. Of course, this still does not work. Let's see. Characters into match per clip. Then, yeah, this looks fine. It's probably like with this offset, maybe, or the kind of want to do turn this into like a put pixel or something in. Put pixel, let's say, with text x size, no, let's say u32, y32, color u32, and if okay, let's take the frame buffer this way. Buffer. So I can just pass the frame buffer. Okay. I need to let's do offset. So y into frame h, right, plus so what I was missing before is I think I'll also need to multiply x with some value since we're like yeah, so how many bytes are in its pixels since we're like moving from pixel to pixel. Bytes, no, bpp, I forgot what the, so yeah, in this case the bpp is 32, so there are 4 bytes in its pixel, but I kind of just wanted to, no, this is bpp divided by 8, right? pixel width, and we multiply that with, well, let's call it bytes per pixel. Yeah, multiply that with, yeah. So there are this many bytes per pixel in in each column, and it's like or let's say um, uh, in the scan line there are this each many pixels, and each pixel is bpp bits wide, right? Yeah, array plus offset. Yeah. Then we color that with the color. Mm. So for now let's yeah, do it in test. 100 rows. Let me put pixel in the frame buffer. Hmm. Kind of need the frame buffer now. Okay, bad idea. Let's do it here. Frame buffer. Let's keep this here. Let's keep all of this here for now. Okay, but for X, I also like, let's just do 0. Let's try to fill the first row, and yeah, color. I don't need the glyph. So let's see if this will work. But there's no frame buffer. Frame buffer. Okay, frame buffer. Be small. What? Frame buffer. Oh, buffer. Okay. Right switch C. Type Q32 font size. Just don't get that. No worries. Yeah, I am kind of seeing let's do like yeah. So I have put pixels also now, right? And Let's do draw glyph. Let's use the frame buffer, the color, and the glyph. Let's okay. So let's start with some row. Let's say 0. No, it's row. And um, so I need the height. I need the header again. Header row dot height. Oh, I mean row is less than header dot height. Let's increase that header. Okay, and each row is going to be 8 bytes, right? So to get that particular, so inside if to get that particular row, what do I need to do? Let's see. Yeah, this should give me the row, right? So I'll need to iterate over the bits as well. Let's do 32 equals 0. So what is the bit? I mean bit index. Um, um, let's just do bit index. How do I get the bit index? So I subtract from 7 minus 4 tenths, and 7 so that it does not go beyond 7. Okay, so our mask is going to be bit index. So I think we're starting from the very end, right? And like in the first iteration, the bit index is going to be 7. So we're like shifting one. So if I have 1, 2, 3, 4, 5, 6, 7, 8, and I'm starting with this bit, right? So this is the LSB, and this is the MSB, right? Okay. If I shift 1/7. I go here. So I was cutting here, right? 1, 2, 3, 4, 5, 6, 7. Yeah, I arrive here, and this is the bit we're going to sort out. So this is the bit our mask is going to test, right? Okay. If this is not equals to 0, then we do put pixel buffer. As for x, I need to ask for x and y as well. X plus the column and y plus the row. Yeah. Okay. Let's get a cliff. It keeps saying cliff. It's cliff. Get cliff font data. Um, where is my font data? Okay. So I have the header, but I don't have the font data. Hmm. Get font data. Yeah. Font data. Character. I don't know. Right. Okay. So we have the diff. Now let's do draw press frame buffer. Let's say 50/50. So we're plotting at 50 color 50. As for the color, yeah, cliff, the cliff that we just saved. Oh, let's see if this will work in the index. Okay. Once again, you know what? Let's just do 16. That's it for now. Let me get this one. Then what is it? What if I do this? Okay, awesome. So I have, oh, finally, I have a amazing. What if I do B? Oh, B. Okay. Oh, I am B. God damn it. This was so like frustrating to set up. But so we have a draw cliff, right? Now what we need to do? We need a drawstring. Drawstring. It takes the frame buffer. I don't need X, Y, and string. It's going to be a non-terminated constant area. That's void. Okay. Okay. Now let's do drawstring. Drawstring frame buffer. As for the string, let's say hello world. Oops. Nope, that didn't work. So let's just do hello in all caps. Let's see if this will work. Nope. Oh, so we're not like moving the positions, right? Okay. So let's start with 50-50. So call, and with each call I increment that by um, frame buffer dot hmm, yeah, is that correct? Um, Oops, I kind of am right somewhere. I know that, but okay. Um, So I'll need to increment by how many pixel is its glyph was, right? So its glyph, uh, uh, so um, the width of each glyph is given by str width, and I need headers with header with, let's see, nope, not sure why, but I kind of getting. Oh, so so this is the exposition. Let's not call it. This got confusing. Let's like this is the white, and I need to increment x by the width, and y is never mutated. Yeah, yeah. Okay, finally. So I have hello. Can I do hello world? Awesome. I can do hello world. Um, I'm probably gonna have to clean this up a bit, but like I'm really tired right now, so I'll do it in a the other stream.